Pythagorean.
Theorem. I can solve
Algebraically.
and
Pythagorean.
theorem.
Good. All right, so let's start with the algebra piece first. On number 1, we have the equation. I'm going to highlight it in green. X plus 2 equals 5, right? What is the first thing we want to do when solving for a variable? What do we want to do? We want to get the variable all alone. So we want this letter to be all by itself. So how am I going to get x by itself? What do I have to do with this positive 2 here? How do you want to do a positive? You use a... How do you want to do addition? You use...
Subtraction.
So we subtracted 2, right? And because we subtracted 2 on this side of the equation, do we have to subtract 2 on this side of the equation?
Yes.
Because equation means equal. So you got to be equal to both sides. So cancels out, cancels out. What's 5 minus 2?
3.
So we still have x. 5 minus 2 is 3. Our answer is x equals 3, right?
Yes.
Look at number 2. We had y minus 5 equals 2. How do you undo subtraction? Everybody, how do you undo subtraction?
Addition.
So we added 5, right? Okay, I'm going to move to 3. Number 3, we had 4h equals 12. We want to get 4 by itself. How do you undo this multiplication problem?
Division.
To get the h by itself, right? Okay. Number 2, missing dimensions. If you look, I'm sorry, number 4 is the problem. If you look at this side, we used guess and check, and we figured out the height is 6, right? If we wanted to use algebra, we figured out, okay, our formula is base times height. Eyes up here. We knew the area was 96. Did we know the area is 96 meters squared?
Yeah.
So we plugged it in, right? Do we know the base? Do we know what the base is?
Yes.
What is it?
16.
So we wrote 16. Do we know the height?
Yes.
Do we know the height?
No.
What is it?
H.
H. Can we solve for h then?
Yes.
You have to get the h by itself. How do you undo multiplication? How do you do this? How do you undo 16 times h? Divide by,
16.
and then we got 6. Last thing we did. So number 5 is another example. I'm going to skip over it. Pythagorean theorem. On the count of 3, what is the formula for the Pythagorean theorem? 1, 2, 3.
A squared plus b squared equals c squared.
So this is the side we call
A.
A. This is the side we call
B.
And these are called what?
Legs.
And C would be called the...
Hypotenuse.
So here's the problem. We need to figure out what this side length is. We need to figure out what C is, right?
Yes.
So if we square 3 and square 4, which is what we're looking at right here, we should be able to figure out what C squared is, right?
Yes.
So what is 3 squared? What is 4 squared?
16.
Do we still know what C squared is yet?
No.
Not yet. Okay. What is 9 plus 16?
25.
So 25. Do we know what C squared is yet?
No.
No. Most of you say, Mr. Pottinger, something times something is 25. That's easy. It's 5, right? But officially, if we want to do the actual algebra, we would use this little symbol called a... And a square root undoes a square exponent, right? So everyone say that out loud. A square root undoes a square exponent. Go. But if we do the square root over here, we can do the square root over here, right?
Yes.
And so we popped out our calculators. Even though we knew the answer was 5, we typed in 25 and we hit the square root button right there, and we got
5.
number 9 is the exact same type of problem. However, we didn't get a nice number like 5. We got a gigantic number like 10.82, blah, 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 and we just rounded it to the nearest hundredth, right?
Yeah.